very appropriate introduction for this section is M31 Andromeda Galaxy. Now, this picture was taken by our club member, John Griffiths, and he did the same techniques as you're seeing in the other pictures tonight. He's stacking photos. He took a lot of 1.5 to 2 minute photos and stacked 220 of them, 6 hours of data to take this picture. But I think this is the cool thing I want you to take away from this. Andromeda Galaxy is one of the 2 or 3 galaxies you can see with the naked eye. If you go camping with us up at Wildcat and you look up, you can actually see the glow of Andromeda. Now imagine standing there in the dark looking up at Andromeda, and now we have a professor of astronomy from Harper College, Bhasker, is going to tell you that our galaxy is flying towards Andromeda, and he's going to tell you what's going to happen. It's kind of cool. So here comes Bhasker. Take it away.
Thank you, Wally. Let me share my screen. Can you all see that?
Yes, we can.
Excellent. Thank you all for being here, and big thanks to the NSA for hosting this event. What you see here is a photograph showing 2 galaxies colliding. In the next few minutes, I'll describe what a galaxy is, what happens when 2 of them collide, and the big collision in our future. You just saw a picture of the Andromeda Galaxy that John Griffiths took. That galaxy will collide with our own galaxy, the Milky Way, in around 4 billion years. Here's another image of the Andromeda Galaxy. This galaxy is also known as Messier 31 or M31. It's actually the most distant object you can see with your naked eye. It's around 2.5 million light years away. If you join the NSA at a dark sky location sometime, one of them will point it out to you. Don't expect it to look anything like it does in this image. It'll look like a piece of cotton. But on this image, we can see the 2 obvious components of every spiral galaxy, or nearly every spiral galaxy, which are the central bulge and the surrounding disk. The bulge looks like a fuzzy yellow ball, but the disk has much more going on. It has spiral arms, and along the spiral arms, we can see dust lanes, clumps of blue stars, and some gas clouds here and there that glow red or pink. Here's another spiral galaxy. It's called the Sombrero Galaxy, or M104. It's nearly edge-on and has a bigger bulge than M31. And here's how our own galaxy, the Milky Way, looks to us. Since we live inside it, it's hard to study its structure. There's a lot of gas and dust in the way. This is with a visible telescope. This is how, well, if you scan the entire sky, take a bunch of images and then stitch them together, this is how it'll look. To the naked eye, it wouldn't look quite this colorful. And with an infrared telescope, you can look through much of the gas and dust and study the bulge in the disk more easily. So far, I've only shown you spiral galaxies. This one here is an elliptical galaxy. It's called M32. The Andromeda Galaxy, again, is M31. M32 is a satellite of M31. You can see M31 in the background. And here is a much larger elliptical galaxy called M87. It's actually much larger even than the Milky Way and Andromeda, which means it's millions of times as massive as M32. This one happens to have something interesting going on in the center. It's got a jet which is propelled by the strong magnetic field of the central black hole. But other than that, this galaxy, like all elliptical galaxies, looks nearly featureless. We don't see any spiral arms, no dust lanes, no glowing gas clouds, and no clumps of bright blue stars. Now here is an irregular galaxy. This one is a satellite of our galaxy, the Milky Way. This one's named after Magellan the Explorer. It's called the Large Magellanic Cloud. There's also the Small Magellanic Cloud, a different galaxy. Irregular galaxies don't have any particular shape, and they don't have spiral arms. But they do contain some features of disks, such as dust, blue stars, and the glowing gas clouds. Stars are actually formed in dusty gas clouds. Those types of things are only present in disks and in irregulars. They're not found in bulges and ellipticals. This means ellipticals and bulges contain only old stars. They don't form new stars. That was my brief overview of different galaxy types. Now let's look at collisions. They're actually quite common. Here's a beautiful galaxy, the Whirlpool Galaxy, M51. You might wonder why I'm showing you this when talking about collisions. There can't be any collision going on here, right? Wrong. This galaxy is actually in the process of colliding with its smaller companion, NGC 5195. And 5195 appears to be deeply disturbed. The technical term for this is galaxy harassment. M51 isn't completely unaffected by the interaction either. If you look closely, you'll see that the right side of the large spiral galaxy is not quite as symmetric as the left side. That's due to tidal forces from NGC 5195, the smaller companion. Here's M81, another beautiful spiral galaxy. And here's its neighbor, M82, which appears to be experiencing all kinds of trauma. What's causing that? Well, M81 is. Here are both of them together, but you might think they still seem a safe distance apart. Well, this is invisible light. Now let's look at radio waves. With the radio telescope, you can look much further out, and you can see that these two galaxies, and in fact, a third galaxy as well, are all already interacting. Here's another galaxy that appears to be having a rough time. And here's more of it on the left. This is the Tadpole Galaxy. What happened is that a smaller galaxy plowed right through it, leaving a tail. And on the right, we see another pair of emerging galaxies with a tail called the Mice. And here's another pair called the Antennae. And here's a close-up of the central region. We see lots of bright blue clumps and glowing gas clouds. That tells us that the star formation here is much more intense than in a normal spiral or irregular. At this rate, all of the available gas will be consumed quickly, and there will be no gas left to form any more stars. Here's one more spectacular collision, and I'll show you one more. Here's Stephan's Quintet. 5 galaxies that are about to collide. 2 of them have already started colliding, and the other 3 appear to be waiting to get in on the action. How about our own galaxy then? Well, it's actually in the process of eating a companion right now. The Sagittarius dwarf spheroidal is slowly being eaten and digested by the Milky Way. In fact, the Milky Way in all large galaxies got so big by eating smaller galaxies. Most of the merging happened early on, over 10 billion years ago. Here's a simulation showing galaxy formation. I'll share this link and all of the links with the NSA so they can post them on the website. So this shows the universe billions of years ago. Tiny galaxies are forming, mostly irregulars and a couple of round ones. And then you see some spiral structure develop in these small galaxies. And then a few of them merge together, and pretty soon you'll see an obvious spiral galaxy slightly above the center here. And then much more merging going on. And pretty soon, pretty much everything we see here will coalesce into one large spiral galaxy. And then this large spiral galaxy will eventually collide with another one that passes by. They don't just collide right away. It takes a while for galaxies to collide, a couple 100 million years. And now all of this is going to turn into a huge spiral galaxy. If there's still gas left after one of these mergers, a new disk will form and you'll still get a spiral. If all the gas gets used up, something else happens. That's what you're going to see soon. Oops. Okay, let's move on. How about elliptical galaxies then? If large spiral galaxies are formed from the mergers of smaller galaxies, are ellipticals the same way? Since most of them are featureless, they don't reveal much about their pasts. But the most massive ones are found at the central regions of dense galaxy clusters, where there should have been lots of merger activity billions of years ago. And a few ellipticals do show some undigested remains of galaxies they ate. This one has lots of dust, which is normally not found in ellipticals. And here's one more that appears to have eaten a spiral. This one also has a jet coming from just outside the central black hole. So what does all this tell us about the upcoming merger between the Milky Way and Andromeda? Here's the projection. This is how Andromeda looks to us now. Seems perfectly harmless. This is Andromeda in 2 billion years. You might still not find it too threatening. Well, how about now? This is 3.75 billion years from now. Soon afterwards, the merger begins. The Milky Way and Andromeda lose their distinct identities. Then the entire sky is bright and messy from all the new star formation triggered by the merger. Gas is getting consumed quickly to form new stars. Then things start to settle down. Not many new stars are born, since most of the available gas has already been used up. Once star formation stops, in around 5 billion years from now, the bright blue stars disappear because they don't live very long. Only the fainter yellow, orange, and red stars are left. And finally, in 7 billion years, we find ourselves in a dense, featureless ball containing yellow, orange, and red stars. In other words, we find ourselves in an elliptical galaxy. When two large spiral galaxies collide, we think the end result will be a huge elliptical galaxy. And finally, here's an animation showing how the entire collision could occur. So here's the Milky Way now, and in the near future, astronomically speaking, the next billion years. So we zoom out, we see Andromeda and a third large member of the local group of galaxies. The third one's called M33. For the next couple billion years, the two big galaxies, the Milky Way and Andromeda, get closer, but they don't quite merge right away. They check each other out, dance around each other, and then the merger begins. Initially, the stars go right past each other, the stars from the two galaxies. There's a lot of space between stars, so the stars don't collide, they just slip right past each other. But the gravity of the two galaxies pulls them back together, and again, they smash together. All the stars have now been randomized in their orbits. The gas has been consumed to form new stars. There's no gas left, and there's a giant elliptical galaxy that just slowly fades away over the billions of years. So that was galaxy collisions in around 15 minutes. Thanks for listening. If you found this interesting, you can take our Stars and Galaxies course or join the NSA. Thanks again.
Thank you. That was very, very interesting. I love the videos and watching how the night sky will change over a billion years. Do we have any questions for Bhasker?
Well, there was one question that came into me, and I shared it with Bhasker, but just in the event he hasn't seen it, if everything in the universe is getting further away, how can we collide with M31? And this question comes from Kathy.
Excellent question. So every group and every cluster of galaxies is moving away from every other group and every other cluster. So things that are far from us, everything beyond the local group is moving away from us. But the things inside of the local group are not moving away from us. So the local group and galaxy clusters as well, groups and clusters are gravitationally bound. Gravity keeps them together. And so inside of groups and clusters, collisions can happen. In clusters, they happened billions of years ago. They're not happening so much anymore, but in groups, they're still happening quite a bit, and they'll continue to happen over the next billions of years.
I've got another question here that has come in. Would this be bright enough to be visible during the day or just at night? And this comes from Bob.
So at the same time this is happening, the sun's also going to die. So that's another big catastrophe that's going to be taking place. So the sun itself is going to be getting larger. It's going to be getting cooler, but much larger. That's going to happen about 5 billion years from now, 5.5 billion years. So while the galaxy is colliding with the Andromeda galaxy, our sun is going to balloon up and get really, really large. Eventually we'll lose our atmosphere. Once we lose our atmosphere, then yeah, there'll be no bright daytime sky. And so you'll see stars even in the daytime. So then you'll definitely see whatever's happening in the galaxy. But even otherwise, yeah, as Andromeda gets closer and closer to us, just like we see the moon in the daytime, we'll start to be able to see Andromeda in the daytime as well. And once the collision is underway, yeah, it'll be dramatic. And there'll be supernova explosions happening frequently. It'll be catastrophic. It'll be intense.
We've got another question, this one from Kiera. Do galaxies ever fall apart?
There's a lot of gravity holding a galaxy together. In fact, we think 90% of the matter or more in a galaxy is made of something we haven't discovered yet called dark matter. And so galaxies don't get torn apart spontaneously. But yes, when two galaxies smash together, you get these huge tails that can get scattered really far. They won't completely leave that local group or the cluster, but yeah, the galaxies can get torn apart through mergers and collisions. But that stuff eventually will get back, and the stars' orbits will get randomized. It will eventually get back. But for a while, yeah, things can really get scattered and be messy. And when I say for a while, I'm talking hundreds of millions of years. Things can be really messy, but eventually gravity should bring them back in. Great questions.
Those are all the questions that I have in my chat. Wally, George, I'm not sure if any have come into your chat.
No, I don't have any at this end.
I don't either.
Okay, thanks again.
Thank you. Very interesting.